And I'm very proud, Peter Pirc, to introduce you to our audience. I hope he's there. Okay, good. And Peter Pirc is presenting virtually on behalf of a FiRa consortium located in Graz, Austria. And UWB is not only, or UWB is not only important for access control, but access control is also important for ultra-wideband. Welcome, Peter Pirc. This is your applause.
Thank you, Ines. Thank you, everyone, for having me. So my name is Peter Pirc. I'm coming from NXP, representing FiRa today. So I work out of Austria, Graz. And first of all, I would like to congratulate to the great demonstration of UWB capabilities. So I really had fun. So really nicely done. And today I'm going to talk about the FiRa consortium and how the UWB is a door opener for the new possibilities. Okay. So you probably noticed in the news that UWB is making headlines. So there's been a lot of attention being made on the market when the first phone based on iOS operating system was issued about 2 years ago, and then followed by the Android phones last year. And also in the automotive area, there are discussions on using UWB for the car access to replace the current technologies and add additional flavor on the security and usability. So all this together is creating a huge wave for the UWB deployment in the market. And the key message is that UWB is happening now as we speak. Okay. So, but let's speak a little bit first about what makes the UWB so unique. So the basic property of the UWB is that it sends very narrow, low energy pulses from the transmitter to the receiver through a certain distance and area. So this area is typically so-called line of sight, so there is a direct path. But in reality, like you have in your showroom right now, and we saw it on the drones, there are many obstacles around the devices or between one device and the other device, which are creating reflections and also causing that then the receiver has troubles receiving the signals and defining which signal is really the direct one, so the so-called first path that is really giving the information of the time of flight and corresponding the distance measurement between devices. And the receivers of today are actually able to really filter out the first path and neglect the other reflections which are seen as disturbance. And this gives us a really unmatched precision compared to other technologies. So UWB can locate precisely down to a few centimeter level distance, and it's 100 to 1,000 times better than the other technologies like Bluetooth or Wi-Fi. So in general, what are the key differentiators of UWB versus other technologies? It is secure, right? It allows the PHY layer, so the physical layer encryption based on the latest IEEE standard. It is real time, so we heard before, it can do the demo that we saw, it can refresh the position 140 times per second, and the technology is capable of much more, up to 1,000 times per second. It can really well coexist with other technology, meaning since it has a very narrow pulses, it can very well coexist, let's say, with Wi-Fi or Bluetooth or other radios. And it is also, due to the same fact, very reliable. Accuracy was already mentioned, so it is very unique. And at the end, due to the very low energy being radiated out, it is also low power. So let's have a look a little bit about the evolution of the UWB. So we all know that this technology was not invented now. It was invented quite some time before, and then it has been specified in the IEEE organization for quite a while, issuing the first version of the spec in 2009, and then followed by several iterations of the specification until 2015. And then lately in 2020, there was an enhanced version released, which is offering enhanced features like secure ranging mentioned before. So along this journey of the technology, there has been also some other milestones which are very important for the understanding of the evolution of this technology. So around 2016, the car connectivity started to look into the options on how to use mobile phones as a car keys, right? And one of the technologies for that is also ultra-wideband. And then in 2019, the FiRa consortium was introduced and founded by the four main companies. So that was Samsung, Bosch, NXP, and ASA ABLOY HID. And the mission of the FiRa consortium is to build the interoperable UWB system for the IoT and mobile devices. And if we look further more what was happening on the market in the past 2 years or past 3 years, is that there has been phones launched on the iOS, on the Android, and earlier this year there have been also UWB trackers launched by the major phone OEMs, which allow really a nice UWB experience. So what are the core services that are becoming a reality today? So I mentioned before, UWB is happening now, right? This means the applications like location-based services or tracking services of items are happening today. So you see here an example of the Samsung SmartTag Plus and the AirTag device, which can be already used now with certain phones that are UWB enabled and give you an option to track items. And through that, it can also deliver some of the services, like, for example, finding a lost device and so on. Then we have a device-to-device use cases where we have two mobile devices interacting with each other, either for the file exchange or for simple data exchange, or for finding each other in a certain space or room. And of course, very important for this session, there is also a hands-free access control systems are being deployed, right? So here we have an example of the announcement from the ASA ABLOY about launching a seamless access control with UWB using phone as the credential. Of course, I listed just few use cases that are available today. And there are many, many other use cases that are to come. So, and here we have a list of some of the key, let's say, verticals on which the industry is working and also FiRa is working, right? So we have the smart cities and mobility, where we have applications like ticket validations or transportation, so the indoor navigation. Then we have a vertical of smart building and industrial, which is taking care about the industrial safety, asset tracking, and the social distancing, very important lately. Then we have smart retail. So just imagine an unmanned store access. So you can access the store, you can even pay seamlessly in such a store once you're exiting. And then followed by the smart home and consumer. And here in the smart home of consumer, we have a use cases like using your mobile phone to point to another UWB-enabled device, like an air condition on our smart TV, which will give you the chance that you can control that particular device, and it will be actually in the context based on the localization. Or you have a use case of the residential access control that is also very, let's say, interesting, or let's say new experience. Then let's have a little bit more look on how the access control is working with the UWB. So we have a mobile phone and we have a door lock installed, and the basic association between those devices or discovery is done through the Bluetooth Low Energy. And over this technology, there is also a basic credential exchange or credential authentication performed, where both devices check if the phone and the door lock are somehow matched together. And then after this check is being done, the digital key is being somehow approved to both sides, which then allows the next step, which is proof of presence. And this is where UWB comes in. So you can really be sure that a phone with a certain credential is present in front of the door lock as we speak. So we are using the time of flight measurement, so measuring how much the signal travels from one side to the other, which gives a very good accuracy, or gives us an indication that that this phone is really present. And then UWB is also used for the intent detection, meaning that you have a certain distance between the door lock and the phone, and then as you move closer, the intent is obvious, so you want to walk through that door, and the door lock can detect this intent and then make either automatic or a manual entrance unlock. So that's about the functionality of the technology. And let's talk a little bit about the market adoption of UWB technology and how does FiRa envision that. I mean, every time you have a large deployment of a certain new technology, it is very much desired that this technology is interoperable between different devices. For example, there is a door lock from manufacturer A that works with the phone from manufacturer A, B, and C. And all this can be achieved only to certain standards or specifications and their interoperability. So, and this is also what FiRa is actually looking for. We're going to talk about the major task of the FiRa a little bit later, but maybe I start to present who we are, so who FiRa is. So we are actually a group of members, of 95 plus members, coming from different ends of the industry, from chip manufacturers, device manufacturers, system integrators, service providers, test labs, test tool developers, and technology providers. So the whole list is really long. So, and I invite you to visit the FiRa Consortium web page, where you can collect more details about every single member. So, speaking about the mission of FiRa, and what are let's say what is the role and the goal of FiRa, right? So FiRa will provide the missing blocks for a broad UWB ecosystem deployment. And this means that based on the technologies of the specification of the IEEE 802.15.4z, enhanced ranging will develop specification and certifications to ensure the interoperability between chipsets and devices. And through that, also promote UWB ecosystems and enable business opportunities, delivering better experiences. And then at the end, establish the FiRa Consortium as a trusted and reliable trademark. So this approach is not something entirely new if you look broader to the technology. So as depicted here on the bottom of the slide, you will see that a similar approach has been done, for example, with Wi-Fi or Zigbee or NFC, and we are simply complementary to the IEEE definition of the technology. A bit more details about the layering and the interoperability with FiRa. So it is very important that devices which are being equipped with UWB chipset, they are interoperable firstly on the lower layers, meaning the physical layers where the hardware and electrical parameters are being set, and then also on one layer higher, which is called MAC or medium abstraction layer, where there are some protocols defined and a basic data exchange and ranging parameters for making the applications. So all this has not been reinvented, but it is based on the IEEE standards. So the FI and the MAC specifications from FiRa consortiums are released already and are available to FiRa members on all levels. So these MAC and FI layers sometimes run entirely in the chipset, right? And sometimes they run partly in the chipset and partly in the software. And the use cases that use these lower layers then are built on a higher layer, which we call it application, right? So on the application layers, we have several use cases already now defined. So access is one of the first one which was defined. And this is now being followed up with the device-to-device definition of the application and the indoor positioning and the real-time location systems. Of course, the definition, only definition of the specification is not good enough. So it has to be topped up with a certification program. This means once the FiRa member develops a device which want to interoperate with other FiRa devices, it is very important to test it. And FiRa is putting in place the interoperability program to check the chipsets and the device and solutions, and also the conformance certification to the FiRa specification. This means that this program is going to ensure the mission of the interoperability and scalability of the UWB technology. Once the FiRa members are certifying the device, they can also get a certification logo, which is indicated that the device has undergone the certain certification program. The certification program and the interoperability program release is planned for the Q4 of this year, which means that we will be seeing the first certified devices out there on the market really soon. Let me just recap our vision. It's to provide seamless user experiences using secured fine ranging and positioning capabilities of the interoperable UWB technologies on various devices. This is very important to understand, and it is going to bring a lot of comfort to the users or to the real deployment and the users of this technology out there on the market. At this occasion, I would also kindly invite you to consider joining the FiRa consortium, so you can get all of the information about the membership levels and how to join on the firaconsortium.org site. Joining the FiRa consortium, of course, it will give you the ability to make FiRa compatible devices and let them be tested, but you can also contribute to the development and deployment of the UWB technology by contributing and actively discussing the different use cases, the specification, the test program, and also marketing side. Good, that is all from my side. So I thank you very much for your attention, and looking forward seeing this technology being deployed further.